This is lesson 2-2, subtracting rational numbers. In this first example, we're going to use a number line. They want us to find -3 minus 2 using a number line. So I'm going to start at -3. That's my first number. So we're starting at -3. And then if we subtract 2, we know our number is getting smaller. The subtraction sign tells you to move to the left. So I'm going to go to the left 2 places. 1, 2. And our answer then is -5. So -3 minus 2 equals -5. Something I want you to notice, though, is instead of doing -3 minus 2, we could do -3 plus a -2. And that would also give us -5. We're going to look in a minute at the subtraction rule and learn that subtraction is the same as adding the opposite. So subtracting 2 is the same thing as us adding a -2. These are the exact same. We get the same answer. Let's do a few more. Again, here we're starting at 2, and then we're subtracting 6. So the subtraction sign tells you to move to the left, and we're moving to the left 6 times. 1, 2, 3, 4, 5, 6. So our answer is -4. Here we're starting at -1. And subtracting 4. I'm going to move to the left. 1, 2, 3, 4. And our answer is -5. On C, starting at -3. And then moving to the left 8 times. 1, 2, 3, 4, 5, 6, 7, 8. For an answer of -11. On D, starting at 7 and subtracting 2. -1, 2. The answer is 5. Now let's look back at all these and apply that rule we were just talking about, that you can change subtraction to adding the opposite. So let's see. Instead of doing 2 minus 6, what if we change it to adding a -6? So we're adding the opposite. Then we could just apply our addition rules. We're adding two numbers with different signs, so we subtract and keep the sign of the larger absolute value. Same answer. Let's try it again. -1 minus 4. Instead of subtracting 4, let's add the opposite of a +4, which is a -4. Now we have addition. Two numbers with the same sign. Remember, when they have the same sign, you add and keep the sign. -1 plus -4. 1 plus 4 is 5. They're both negative. Our answer is negative. Again, same answer. Let's try it on C. -3 minus 8. So again, instead of subtracting, we'll add the opposite and apply our rules of addition. We're adding two numbers with the same sign. They're both negative, so my answer is negative. And again, since they're the same sign, we'll add the numbers 8 plus 3, and that gives us 11. Same answer. Let's try it on the last one. Instead of 7 minus 2, we'll do 7 plus a -2. Add the opposite. And then apply the rules of addition. We're adding numbers with different signs, so we subtract. 7 minus 2 is 5. And keep the sign of the larger absolute value, which would be 7. And again, you see, we get the same answer. Let's try it again on this example. Find 4 minus a -2. So again, I'm going to try adding the opposite. So we know subtraction is the same as adding the opposite. So you change two signs. Every time you have to change. Also, we learned in 2-1 that when you have two negatives next to each other, they actually form a positive because it's the opposite of -2, which gives you a +2. So we're doing 4 plus 2, which is just 6. Try that on a few more. Let's practice our adding the opposite. So instead of 4 minus 5, I'm going to add the opposite. So you see we still have that negative, 4 plus a -5, which is the same as 4 minus 5, and then we apply the rules of addition. We're adding two numbers that have different signs, so we have to subtract. 5 minus 4 is 1. 5 is larger and it's negative, so our answer is negative. Try it on B. Again, two negatives make a positive, or subtraction is the same as adding the opposite. So you have to change, just like we did here. Change. You change two signs. Change subtraction to addition, and change the sign on your number. If it's negative, change it to positive. If it's positive, change it to negative. So 5 plus 9, we're adding two numbers with the same signs. They're both positive. Our answer is positive. Just adding on that one. On C, again, a double negative creates a positive. We know that subtraction is the same as adding the opposite. And now we just treat it like an addition problem. So we ask ourselves, same sign or different sign? They have different signs, a -6 and a +10. When they have different signs, we subtract. 10 minus 6 is 4. And keep the sign of the larger absolute value, which would be 10. It's positive. Our answer is positive. Last one, 6 minus 3. This one you should already know the answer to. 6 minus 3 is 3, but let's apply our rule to change, or add the opposite. 6 plus negative 3 is also 3 because they have different signs, so we subtract. 6 minus 3 is 3. Keep the sign of the larger absolute value, which is 6. It's positive, so our answer is positive. Aha, here we are. The rule, subtracting numbers. It's the subtracting numbers rule. To subtract a number, add its opposite, which is what we were just talking about. So let's put a little example up there of what we're talking about. If you're going to do 2 minus 6, which equals negative 4, then we're going to add the opposite. So the same thing as doing 2 plus negative 6, and then we apply the rules of addition, which say that since they have different signs, we subtract. 6 minus 2 is 4, and 6 is larger, it's negative, so our answer is negative. You could even flip it around. 6 minus 2 equals 4, and instead of subtraction, we can add a negative 2, which is still 4 when we apply the rules of addition. They have different signs, so we subtract them. 6 minus 2 is 4. 6 is the larger absolute value, so the answer is 4. Subtracting rational numbers. Simplify each expression. So we're just applying that rule over and over and over. Subtraction is the same as adding the opposite. And then we just apply the rules of addition. Do they have the same sign or different sign? Negative 11 and 6/10, positive 14. So they have different signs, so we subtract. 14 minus 11 and 6/10. Remember that you have to line up the decimals. If you can't find the decimal, it's behind it. So the decimal is behind 14. You can add a 0 onto the end. Borrow from the 4, it becomes a 3. 10 minus 6 is 4. Bring down your decimal. 3 minus 1 is 2, and 1 minus 1 is 0. So our answer is 2 and 4/10. Look for the sign. 14 is bigger. It's positive. Our answer is positive. Here we have some fractions. We know we can't do anything with fractions, so we change the denominator. But I'm going to start with changing these signs here. So instead of subtracting, we add the opposite. Change both your signs. And now I'm going to get a common denominator of 9. So 3 times 3 is 9. 2 times 3 is 6. Plus 4/9. That stays the same. 6 plus 4 is 10. 9, so we can change it to a mixed number. 9 goes into 10 one time with 1 left over. 1 and 1/9. Let's do a few more like that. So we're still applying our rule of adding the opposite. Subtraction is the same as adding the opposite. Change. Now we just apply our rules of addition. So once you've changed your subtraction problem to an addition problem, then you just use your rules of addition. So they have the same sign, so we add. They're both negative. Our answer is negative. 6 plus 2 is 8. On B, again, subtraction is the same as adding the opposite. Change. Now we apply the rules of addition. Same sign or different sign. They're both positive, so just add them. 8 plus 4 is 12. On C, add the opposite. They have the same sign, so we add them. 4 and 3/10 plus 3 and 7/10. Line up the decimals. 3 plus 7 is 10. Bring down your decimal. Carry that 1. And that's 8. So 3 and 7/10 plus 4 and 3/10 is simply 8. It's a positive 8 because they're both 8. And then on D, on the fraction, again, subtraction is the same as adding the opposite. Change. And but before we can add our fractions, we need a common denominator for 9 and 6, which would be 18. This is a negative something plus something else over 18. We multiply this times 2, so 8 times 2 is 16. 6 times 3 is 18. 5 times 3 is 15. And then apply the rules of addition. Negative 16/18, positive 15/18, they have different signs. So we subtract. 16 minus 15 is 1. Keep your denominator. And 16 is larger than 15, or 16/18 is larger than 15/18. So we keep the sign of negative 16/18, and our answer is negative 1/18. Example 4, absolute values. Simplify the absolute value of negative 13 minus negative 21. And I know that this looks complicated, but it's really not. Treat your absolute value symbols like a grouping symbol. That means that everything has to be done inside them before you take the absolute value. So what some people might want to do is just erase all the negatives, because that's what we think of when we think of absolute value. But we can't do that until the very last step. So right now, we're just going to treat this problem like all these other problems. So I'm going to start by subtraction is the same as adding the opposite. So I have the absolute value of negative 13 plus 21. And you don't have to rewrite it if you don't want to, but I did just to clean it up. And then we'll, again, inside the absolute value, we want to simplify this, apply the rules of addition. They're the same sign or different signs. This number's negative, this number's positive. They have different signs, so we need to subtract 21 minus 13, which gives us the absolute value of 8. And it's positive 8 because 21 is larger and it's positive, and the absolute value of 8 is just 8. Let's look at a few more of those. Or at least, there they are. So on A, the absolute value of 8 minus 7. Well, again, simplify what's in the absolute value, then take the absolute value. So 8 minus 7 is the same as adding the opposite. And I know you can do 8 minus 7 without doing that. We're just practicing our rule of adding the opposite. You already know 8 minus 7 is 1. 8 plus negative 7 is still 1. They have different signs. Subtract. 8 minus 7 is 1. Keep the sign of the larger absolute value, which is 8, and the absolute value of 1 is just 1. On B, now look, we have the same numbers, we just switched them around. So remember, subtraction is the same as adding the opposite. And then we apply our rules of addition. They have different signs, so we subtract. 8 minus 7 is 1. 8 is larger and it's negative, so is our number. And lastly, we take the absolute value of negative 1, which is 1. The last thing you do is always to take the absolute value. C, subtraction is the same as adding the opposite. So we have 10 plus 4. They have the same signs. 10 plus 4 is 14. So the absolute value of 14, which is 14. Last one, negative 4 minus a negative 10. So subtraction is the same as adding the opposite. And now they have different signs. Negative 4 plus positive 10. So when they have different signs, we have to subtract. 10 minus 4 is 6, the absolute value of 6. And it's a positive 6 because 10 is bigger and it's positive. And the absolute value of 6 is 6. Example 5, evaluating expressions. Remember that evaluate just means to solve. But when we solve these kind of problems, we have to substitute first. Also, don't let all these negatives confuse you. You've got to leave your problem just like it is. So you have to have these two negatives here. The only things we're changing are x and y. So instead of x, we're going to plug in negative 3. And instead of y, we're going to plug in negative 6. So x is negative 3. I'm going to leave these minus the negative, leaving all this alone. I just brought it down. And now I'm going to substitute y, which is negative 6. And I know that this looks crazy. There are all these negatives everywhere. Ooh, kind of hurt your head a little bit. But let's first take these two negatives that are inside the parentheses. Remember that this means the opposite of negative 6. When you have two negatives next to each other, it means the opposite of negative 6. And the opposite of negative 6 is positive 6. You can also take this negative sign, rotate it, and put it on top of your other one and create a plus sign. So we have negative 3 minus 6. Okay, I'm going to rewrite that because otherwise this gets real messy. So I have negative 3 minus 6. That's what I end up with now. Let me put this plus sign back so you can see every step we've done, or the subtraction sign back. So what I did then is I took this double negative. A double negative creates a positive. So I changed it both to positive. So we ended up with negative 3 minus 6. And now we'll apply our rules of subtraction, which says it's the same as adding the opposite. And I know we went kind of back and forth with all those negatives, but this is kind of a crazy problem. So now we can apply our rules of addition. We're adding two numbers with the same sign. Negative 3 plus negative 6, they're both negative, so our answer is negative. 3 plus 6 is 9, negative 9. Whew, that was a crazy problem. Let's try some more. So we're doing the same thing. Evaluate for t is negative 2 and r is negative 7. So I'm going to start by substituting. R is negative 7 minus, bring my minus down, and t is negative 2. Negative 2. So just like we've been doing, we have to remember that subtraction is the same as adding the opposite, and then apply our rules of addition. Negative 7 plus 2, they have different signs, so we subtract. 7 minus 2 is 5, and keep the sign of the larger absolute value. 7 is bigger than 2, it's negative. Our answer is negative. On B, again, substitute first. What is t? T is negative 2 minus, what is r? Negative 7. Notice that I left this minus in. We have to copy everything exactly. Just change your letters into numbers, but leave everything else alone. And then we'll apply our rules of subtraction, which says subtraction is the same as adding the opposite. And then apply the rules of addition. We are adding two numbers with different signs, a negative 2 and a positive 7. So we have to subtract. 7 minus 2 is 5, and keep the sign of the larger absolute value, which is 7. It's positive. Our answer is positive. Ooh, C, looking kind of tough. Here's where we have all those extra negatives thrown in there. So bring this negative down. T is negative 2 minus, bring that minus down, R is negative 7. Whew. Let's deal with these negatives first. Again, when you have these two negatives next to each other, you know that it means the opposite of negative 2. What's the opposite of negative 2? A positive 2. So change. Same thing here. Subtraction is the same as adding the opposite. So all those negatives just became positive, but not just by magic, but because double negatives create a positive, just like we talked about in our last lesson. If I said I don't have no dogs, really what I've said is I do have dogs. So a double negative creates a positive. Now we're just adding 2 plus 7, which is 9. Isn't that crazy that something that looked so negative actually ends up positive? So let's look at D. This one has even more negatives thrown in there. Again, we're substituting, so this is the opposite. You can even read this as the opposite of R. So R is negative 7 minus, and then you would read this the same way, the opposite of T. The opposite of T. T is negative 2. So let's deal with these negatives first. The opposite of negative 7. The opposite of negative 7 is a positive 7. Same thing with the negatives in here. The opposite of negative 2 is positive 2. Now I'm going to go on to the next line and rewrite this because it's getting kind of messy with all these negatives turned into positives. So now I have 7 minus 2. Look how much simpler it looks now. So you can either solve it right now, 7 minus 2 is 5, or you can remember that subtraction is the same as adding the opposite, but either way you still get 5. Last example. The temperature in Montreal, Canada at 6 p.m. was negative 8 degrees Fahrenheit. That looks important. Find the temperature at 10 p.m. if it fell 7 degrees. They want us to find the temperature. And the only way we're going to find it is by solving this problem. We started at negative 8 degrees. Then it fell 7 degrees. So if it's falling, then it's negative. It fell 7 degrees. And then we just use our rules of subtraction. Subtraction is the same as adding the opposite. So we're adding two negatives together. Negative 8 plus negative 7. 8 plus 7 is 15. They're both negative, so our answer is negative. And if you think about that, doesn't that make sense? If you have this thermometer and you're at negative 8 and it fell 7 degrees, fell 1 degree, 2 degrees, 3 degrees, 4 degrees, 5 degrees, 6 degrees, 7 degrees. If you start at negative 8 and you go down 7 degrees, 1, 2, 3, 4, 5, 6, 7, then you're going to be at negative 15. That's what I always say. If you start out negative and then you're more negative, then of course your answer is going to be real negative. Okay, well that's it for 2-2. Good luck.